In the last class, we learned about compounding and discounting. So the first important discounting method is net present value method. Net present value discounts future cash flows to get the present value. So in a single sentence, you will get to know what is net present value method. It is the difference between the total present value of cash inflows and the total present value of cash outflows. That gives you the net present value. The net present value can be positive or negative. It is positive when the inflows are more than the outflows. That is when the total present value of cash inflows are more than the present value of cash outflows. It is a positive NPV, which also means that the actual rate of return is more than the discount rate. There can be a negative NPV if the difference between the total present value of cash inflows is less than the total present value of cash outflows, which also means the actual rate of return is less than the discount rate. So how do we determine this discount rate? It is actually the rate of return desired by the investor, or it is the minimum rate of return required for the investor to take up the project. And this minimum rate of return is called as the cost of capital. In short, we can say that the discount rate is the company's cost of capital. And what does this NPV represent? It represents the returns of the company's shareholders which they receive over and above the cost of capital. A positive NPV contributes to the wealth of the shareholders. Why? Because it means that the actual rate of return is more than the discount rate or the cost of capital. And that is why the NPV method is also called as the investor's method. Let us see the computation procedure of NPV. The first step is determination of minimum rate of return. That is, we have to know what is the R or the discount rate, which is actually the minimum rate of return that the investors expect, or it is also called as the cost of capital. The second step is computation of PV of cash inflows and outflows. Usually the investment is made at the beginning of the year or in the beginning period. So that amount itself becomes the present value. But we have to find the present value of cash inflows. And for this we have to go back to that formula where PV is equal to future value divided by 1 plus R whole raised to n. We have to find separate PV value for each year. Since we have to find the present value of cash inflows, we represent it by C1, C2 and Cn. So to find the PV for the first year, it is C1 divided by 1 plus R. For the second year, it is C2 divided by 1 plus R whole raised to 2. For the third year, it is C3 divided by 1 plus R whole raised to 3, and so on till Cn divided by 1 plus R whole raised to n, depending upon the life of the project. So we have to add all these PV values and then we get the total PV of the cash inflow. Presently, we do not have to use the formula. We can use the present value table instead. That is, we get the value of 1 divided by 1 plus R whole raised to n from the present value table. And that value is actually the discount factor. So to find the PV of a particular year, you have to find the discount value of the concerned period and multiply it with the cash inflow, and you will get the present value of the corresponding year. Finally, you will have to compute the NPV. It is what the difference between total present value of cash inflows and the total present value of cash outflows. And that is the procedure of NPV. We shall look into a problem to better understand this concept. There are two projects, Project A and Project B. You can see the initial investment is rupees 1 lakh in both the cases. In Project A, you can see the following cash inflows. The first year rupees 30,000, second year 40,000, third year 40,000, fourth year 30,000, and fifth year again 30,000. So here the discounting factor is 15%. So you should refer the present value table and find what is the discount factor at 15% for 1 year. It is 0.87. So multiply 30,000 with 0.87 and you get 26,100. Similarly, find the discount factor for the second year at 15% and it is 0.756. And to get the amount 30,240. Again for the third year, discount factor at 15% is 0.658. Multiply 40,000 with 0.658 and you get 26,320. Similarly, do it for the fourth year and fifth year and you will get 17,160 and 14,910 respectively. Total the amounts, that is of first year, second year, third year, fourth year and fifth year, and you get it as 1,14,730 as the total of the present value of cash inflows. Alright, similarly do for the project B also. Multiply the inflow with the corresponding discount factor and you will get the present value of each year, total of the present values, and you will get 1,10,770. Okay, from these amounts you have to reduce the present value of cash outflow, that is your initial investment of 1 lakh. So when you reduce 1 lakh in project A from the total of present value, you get 14,730 as your NPV. In project B, when you reduce 1 lakh from 1,10,770, you get an amount of 10,770. So you can see here that the project A's NPV is greater than that of the project B. So we can conclude that project A is better than project B because the NPV of project A is higher.